record again. Okay, sweet. So we just learned what functions were, and now we have applications of linear functions. So let's see what this is all about. And you're pretty sure you'll need a calculator. All right. So number one, if 1 gallon of gas costs $2.50, how much will it cost to fill a 15-gallon tank? Solve this by using a proportion, a conversion, and a linear function, and explain why they all give the same answer. Oh, that's fun. Okay. So let's look at A. Okay. So if we wanted to set up a proportion for this, let's see. So our proportion, we would say that 1 gallon of gas cost $2.50. So $2.50. Okay. And then we want to know how much will it cost to fill a 15-gallon tank. So we're going to put 15 gallons there and put it over X amount of money. So I'll just leave it as X. Okay. Well, fair enough. We probably knew from the beginning that we should have just multiplied it by 15, right? Oops. So by a proportion, if we solve it, you cross multiply and you'll get X equals, and what is 2.5 times 15?
$37.5.
37.5. So it'll cost $37.50. Okay, so that was doing the proportion. Now, if we tried it by a conversion, so conversion, gallons to dollars. So we know that with our conversion, let's see, gallons to dollars. So we know that 1 gallon is equal to $2.50. So if we wanted to go from gallons to dollars, I think we would set this up as we're going to do 15 gallons. And then if I do my multiplication tables, you would put 1 gallon over $2.50 or under $2.50. And once again, your gallons would cancel and you would have 15 times 250, which again would give you $37.50. Okay, so we see one was using algebra, the other was just straight do 15 times 250. Of course, it used the conversion table. And then C wants us to write this as a linear function. Okay, so for C, this one might be a little more crazy. Let's see. For C, we want this as a linear function. Now remember, a linear function is given as y equals mx plus b. Okay. So how could we fill this in for our linear function? So for every gallon, it's going to cost us $2.50. So should that be our slope or should that be our y-intercept? And I guess to dig in more on this is that if you're ever setting up a linear function to represent cost or anything like that, So your linear function is always going to be a variable cost plus a fixed cost. So out of 250, and if it's going to be 15 gallons, which one do you think would be a variable cost?
Wouldn't it be the 15 gallons?
Well, so whenever I say variable cost, I'm meaning that it's a slope, right? So is it, if we put the 15 in there, so let's just check that out. If we put the 15 in there, this means that you are now going to be paying $15 per gallon. Is that what we want to do?
No,
Because how much does it cost per gallon?
250.
$2.50. Okay. So instead, we're going to put in that 250. So you would get y equals 250x. Okay. And our fixed cost here is just going to be 0. So fixed cost always means something like, in terms of a cost function, like how much would it cost if you were to drive your car to the store every day? How much would it cost for the gas actually to be delivered to the store? And that's not anything we have to worry about. The only thing we're worried about is how we fill up our tank. And we only have to worry about the variable cost right now. So we know that it's 250 per gallon of gas. So that X represents every gallon of gas. So if we wrote this as a linear function, y equals 250x, then all we would have to do is plug in 15, and you would get y equals 250 times 15. And guess what we would get again?
37.5.
37.5. I guess this question just wants us to ponder. So D says, explain in your own words why they all give the same answer. What do you guys think? Why do we get the same answer when we use a proportion, a conversion, and a linear function?
I mean, because we're just multiplying the cost of gas to how many gallons of it is.
That's that's good enough for me. Yeah, I mean, because it's just a simple multiplication problem. So in the proportion, we're doing 250 times 15. In the conversion, you're doing 250 times 15. And in the linear function, you're also doing 250 times 15. So no matter how you set it up, by proportion, conversion, or linear function, we are still multiplying the cost of gas per gallon. So let's say in all examples, we are multiplying the cost of gas, oops, by how many gallons? That's it. So it doesn't matter if we set a proportion, conversion, linear function, no matter what, They're all multiplying the cost of gas times how many gallons we need. So that's it. Okay. Everybody good with that one? Okay. Then in number 2, look up the cost per credit hour at NVC and UTSA to answer the following. How much would it cost to take 12 credit hours at each school? And what other cost does this fail to take into account? Okay, that is fun. So let's go look. Everybody get on Google's and let's see if we can pop this up. Let's say cost per credit hour at UTSA. Oh, wow. It instantly pops up in Google. That's pretty cool. Look at that. Cost per credit hour at UTSA. 30 per semester credit hour charge. The minimum charge is 120 and the maximum charge is 360 per semester. Okay. And then we can look up cost per credit hour at Vista. So let me write that down. So UTSA is 30 per. And then NVC, let's see if that pops up. Cost per credit hour at Alamo colleges. That one's not going to be so easy, huh? Northwest Vista. Let's see. Part-time tuition and fees. See what that pops up. Anybody find it yet? Independent in district. 2 semesters. New tuition rate will be $13 more in the spring. Well, how much is it? Hmm.
I think it's $99 per credit for in-district residents.
$99 per credit hour. Huh.
And 3 credit classes is $297.
So it's weird because it says it's a flat rate of $480 for 1 to 6 credit hours. So I just divided 480 by 6 and that gives me 80.
$80. Huh. That would seem to be a lot more than UTSA, right?
Yes, sir.
Which doesn't make sense, right?
Nope.
Let's see. Huh?
Which
Hey,
is
this
schools.
is some good information to find out, huh? How much is a semester at Northwest Vista? Yeah, right. It's still cheap, but I don't think it's that much, right? If it says $99 per credit hour, that's a lot of money though. Let me text my teacher friend, like, how much is it? In-state, $215 per credit. I don't know. That's some good stuff to find out. Let me text them. Charge per credit hour. UTSA's popped up like nothing. To me, that's that. I guess we'll never find out.
So Professor, on the Alamo College's schedule of tuition,
Mm-hmm.
it shows $99 per credit hour.
Per credit hour, right?
Mm-hmm.
I'm seeing that, but I can't believe that UTSA is 30, you know?
Yeah, let's look at UTSA again. I don't think that's right.
No. All right, let's look at UTSA again. This is why you don't believe the internet. Oh, there it is. Look at that. $450 per credit hour.
That sounds about right.
That sounds much better. Okay. Sweet. Okay. We have it. All right. Now it all makes sense. I was like, there's no way that UTSA is less expensive than Vista. $450 per and $99 per. Okay. So if you're going to UTSA, how much are you going to pay for 12 credit hours?
$1,400.
12,000. Wait. You say 5,400?
Yeah.
Okay. $5,400. And then at Vista, you will pay
$1,188.
that's a deal. Okay. Now that we figured that out. Okay. Sweet. So UTSA full-time 5,400 and then MVC 1,188. And what other costs do you think they fail to put in there?
Books,
Books,
lab fees.
Ooh, lab fees,
Taxes.
taxes, good. What's that one that they got sued for? The recreational fees. So when the pandemic hit, people were still getting charged for recreational fees when they couldn't even use the campus gym. So they had to give all that back. How about just fees in general, right? Oh yeah, cool. So that was good to find out. Okay. I wouldn't even want to look up UT or UIW. That's probably gonna be a lot more. Actually, I know UT. I was playing disc golf this morning with another instructor, and he said his son's going to UT and they're shelling out 11 grand a semester. Insane.
That's crazy.
Yeah. Okay, cool. All right, number 3. Mr. Thompson is on a diet. The graph below shows his weight over time. How much did he weigh when he started the diet? How much weight did he lose every month? And estimate how long he has to be on the diet to weigh 198 pounds. Okay. So how much did Mr. Thompson weigh when he started on the diet? So we have to look at 0 months, right? So at 0 months, how much did Mr. Thompson weigh?
260.
Good. So 260 pounds. Okay, cool. And then B, how much weight did he lose every month? So I think we'd have to be smart here and try to find a slope, right? So what looks on this graph, what looks like the next clearest point that you could find?
Five.
At 5 months, right? Right here. So if we
Yes.
wanted to use a slope, this means from 260, we went down from 260 to 240. So we're going to be looking at a slope here. So our rise means we dropped 20. So we went 20. And how far did we run?
5.
1, 2, 3, 4, 5. So 20 over 5. So how many pounds did he lose per month?
4.
4 pounds per month. Oh, that's pretty good. 4 pounds per month. Okay. And then C, estimate how long he has to be on the diet to weigh 198 pounds. So how do you guys think we would estimate that? So how many more months until he's at around 198 pounds? If he's losing 4 pounds per month. So we found out after 5 months, he was at 240. So we lost 20 pounds in 5 months. And then the next clearest point looks like it's at 10 months. And in 10 months, he's at 220 pounds. So this means in another 5 months, where do you think it would be? If he keeps following the same trend.
220.
At well, he's already at 220 at 10 months, right? So let's say in 15 months, where do you think he'll be?
200.
200. And we want to get close to 189. So in 15 months, he's 200. How many months do you think it would take for him to get to 198? Or actually, he's at 200. No, never mind. Sorry. I was thinking 189. I was being dyslexic. So actually, in 15 months, right? He'll be at 200. Good. So 15 months, we're going to say approximately 15 months. Okay, because it's every 5 months, he's losing 20 pounds. So after 5 months, he was at 240. After 10 months, he's at 220. After 15 months, he's at 200. So in approximately 15 months, maybe 16, he'll be at 198 pounds. Okay, not bad. All right. All right. 4. Kara uses the linear model. F of x equals 20,000 plus 0.3x to predict her total salary from achieving total sales of x. Interpret the slope and the y-intercept in terms of her salary and sales. So again, this is where the definition of a linear model comes in. I wrote it above on the very first example, but I'll do it again here. To write a linear model, it's always a variable cost plus a fixed cost. And it doesn't have to be cost. It could also be like a fixed revenue or a fixed profit, but this is just the basic linear model format. So variable cost, which also means slope. Okay. And if we look at our given function, f of x, and I rewrite it with the x term first, 0.3x plus $20,000, what do you think the slope means when Kara uses this function to predict her total salary from achieving total sales of x? So what does the slope mean in all this? Actually, what is the slope, first of all?
0.3.
What was that?
0.3.
0.3. Good. And is that slope positive or negative?
Positive.
Positive. So that's good that it's positive, because if Kara is predicting her total paycheck, this means that if it's a positive slope, for every sale that she makes, her paycheck should be increasing or decreasing?
Increasing.
Increasing. Good. So this is a positive slope, which means that every time she makes a sale of X, her paycheck, her salary, will increase. Okay. And now let's say that, or actually, let's figure out what that 20,000 is. So in this case, it's a function that models her paycheck, so what she's gaining. So this 20,000 is going to be called our fixed, when we'll call it, we'll call it our fixed salary, which is 20,000. But what does this mean? So remember, her paychecks increase if she makes sales. If she doesn't make any sales, let's say she made 0 sales, how much money would she still make?
$20,000.
$20,000. So no matter what, if Kara just sits there, maybe goes on vacation for the whole year, no matter what, she's going to make $20,000 on her check. And it's not bad. I mean, if it's for a whole year, that's not good. But if it's for a month, I'll take it. So no matter what, if Kara doesn't make any sales at all, she will make a $20,000 salary. So that is your fixed cost, your fixed amount. Okay. I guess I could just leave it like that. That's fine. So the slope, oh, and I guess, yes, this is also the y-intercept. Okay, cool. So any questions on this page? Everybody good with this? All right. A lot of thinkers on this one. No real math. Okay, cool. What's on this page? Sweet. Okay, so 5. Joe has a part-time job caring for and walking dogs. He estimates that his annual insurance, etc., is $420. On average, he spends $4.50 on gasoline per visit. He charges $15 per visit. Note that this is Note that this is an annual cost function. Hey, so this is going to be using that function I keep writing. So if it's an annual cost function, it's again going to be variable cost plus fixed cost. Okay, so explain how to find his total cost, fill in the tables for the values below, and suppose his budget is $1,000. How many visits could he make annually? Okay, so out of all of this, we want to know what Joe's part-time job is costing him to run his own business, his own little part-time job of walking dogs. So what do you think is fixed cost? What comes out of his pocket every year?
Insurance?
Insurance and whatever else, right? So he estimates that his annual insurance and etc. is $420. So this is going to go under A. So we know that his fixed cost, no matter what, even if he's not working, he's still going to pay $420. Okay. And then it says, on average, if he's going to go walk dogs, he spends $4.50 on gasoline per visit, and then he charges $15 per visit. Now, we only want to represent this as a cost function. So is the $4.50 the one that cost us, or is it the $15 that cost us?
The 450.
It's the $4.50. Good, because in order to go walk the dogs, he spends $4.50 on gasoline per visit. So our variable cost is going to be $4.50 X, where X represents every visit. So put these two together for our cost function, and we'll get Y equals 450X plus $420. So this is his cost function. This is everything he does that costs him money. Okay, so that's done. Now B says, fill in the table for the values below. So for B, all we have to do is take all of these values, 1, 2, 3, and 4, and plug them in for which variable?
Yeah.
Plug them in for X. Okay, cool. So if we start at 0, you have, so I'll say when x is 0, you get y equals 450 times 0 plus 420. And then when x is 1, you get y equals 450 times 1 plus 420, and so on and so forth until we get to 4. Y equals 450 times 2 plus 420. And when x is 3, y equals 450 times 3 plus 420. And when x is 4, y equals 450 times 4 plus 420. Okay, 0's easy. So if he does 0 visits, he'll have to pay what amount no matter what?
420.
$420. Good. That'll go right there. If he does 1 visit, how much does he pay?
$424.
$424.50. Oops. $424.50. And if he does 2 visits, how much money?
$429.
$429. And if he does 3 visits, what do we have?
$433.50.
$433.50. Cool. And then if he does 4 visits, what do we have?
$438.
$438. Okay, cool. All right. So that finishes B. So all we had to do is plug in those X values into our linear model. And then C says, suppose his budget is $1,000. How many visits could he make annually? So for C, it's kind of like the questions we handled earlier today. So for C, they say when he has a budget of $1,000, how many visits could he make? So remember, X represents the amount of visits in this problem. Okay, so for C, we just have to plug in 1,000 for Y and solve for X. So for C, you would have 1,000 equal to 450x plus 420. Okay. And now let's go ahead and solve for X. You are going to subtract that 420 to the left side. And what is 1,000 minus 420?
$580.
580. Good. 580 equal to 450x. And then divide everything by 450. What do we get?
$128.88.
128.88. So 128.88 equal to X. So he can make approximately around 129 visits. Well, you can also find how much he makes by taking that 129 visits and multiply it by what? So remember, he makes 15 per visit. So if you, I mean, it's not asking us to, but if we wanted to, you can multiply that by 15 and you would see that he makes $1,935. So yeah, not bad. But again, we didn't have to find that. All right, what's left? Number 6, number 7, okay, cool. Let's go ahead and finish these on Wednesday. So we'll stop there. Okay. Everybody good?
My brain hurts.
Same here.
Yeah. It's the application of linear function. I think because it was more like, we didn't really do much math, right? It was more thinking. Okay, sweet. So that finishes there.